So suppose we've got this integral and we wanted to look at the n equals 1 case and f is even. Then we only need to use a semicircular contour. And we only need to do the n rather than the n plus 1 case. So let's just see what happens when n equals 1. So it's just n equals 1, just see what happens. So we just get I1 when we integrate along here. I'm going to skip what happens when we integrate along here and around here and hope they go to 0. You need to check this, depends on f. And so I'll just write that as goes to 0, perhaps, hopefully. And then along here, as before, we have z equals x e to the I pi. Sorry, I'll write it as r e to the I pi, which gives us dz along there is equal to minus dr. So I get a minus sign, and it's from infinity to 0. And I've got f of minus r, which is equal to f of r. So I've just got f of r, and log of r plus I pi, since n is 1, dr. So this gives me, using the minus to swap the limits, this integral here is precisely the integral I want to find, n equals 1. So I get twice the integral I want, 2i1. And remember, I'm using this minus to swap the limits, so I've got a plus sign here, and then I've got plus I pi times I0, which is just the integral of f of r. So I've got 2i1 plus I pi I0 is equal to 2 pi I times the sum of the residues of f of z log z. And what I can do at this point, in most cases f will be real, which means that in will be real. I can just, if I want I1, so I can just take the real part, and then I don't have to work out what I0 is. So dividing by 2 and taking the real part, I've got I1 is the real part of I pi times the sum of the residues of all this stuff. Now let's think about what happens here. So the residue, sum of the residues, is going to have a real part and an imaginary part. Now the real part of this, when it's multiplied by I pi, will give you an imaginary number. So we don't want that. We only want the imaginary part of the sum of the residues. When that's multiplied, or I should say I times the imaginary part, when that's multiplied by I, it's I times the imaginary part times I gives you a minus sign. So you end up with, this is the same as minus the imaginary part of pi times the sum of the residues of this thing. Okay. So again, this formula here is not something you should try to remember, but it's just something to be aware of, that again there's this trick of taking either the real or the imaginary parts of an equation to save you a lot of work. This really is saving you a lot of work, because if you didn't do this, then you'd have to work out I0 separately, but then you'd be wasting your time, because I0 just comes from the real parts of the residue.